Now for our next example, we have 3 less than or equal to 2x plus 1, which in turn is less than 9. Now it should seem reasonable, I hope, that our goal will be to try to end up having x isolated in the middle here. And so to accomplish that, what we need to do first is subtract 1 from each part. And then doing that, we have then 2 less than or equal to 2x, which in turn is less than 8. And to finish up then, what we'll need to do is divide each part by 2. So we have then 1 less than or equal to x, which is less than 4. And we could, if we would like, express that then in interval notation by writing 1 with a bracket there, comma 4 parentheses. And we can easily graph that on a number line, so we'll do that next. Now, being a very keen observer, as I'm sure you are, I imagine you noticed the solution to this problem was the same as to the previous one. And so to understand the relationship between these two, let's sidestep for just a moment to establish a basic principle. So whenever you see an inequality of the form a less than x less than b, it can always be rewritten or split up as two separate inequalities joined by the word and. So that is equivalent to writing then a less than x and x less than b. And notice that the inequality arrows must point to the same letter when you split it up as it does in the original form. So now if we look at the problem that we had at the very beginning here then, 3 less than or equal to 2x plus 1 less than 9, that can be rewritten then as 3 less than or equal to 2x plus 1 and 2x plus 1 is less than 9. And I think you'll notice then that this form, as the two separate inequalities, is exactly the same as in the previous problem. So that's why these two turned out to have the same solution. But I think you might agree that it would be more efficient probably to solve the problem in combined form like we see here at the top than rewriting it as two separate inequalities. But certainly both are correct and valid approaches.